Hello and welcome to a new video series I like to call Robby's Rock Collection. Every week I'm going to go through a selection of the geologic specimens that I've picked up over the years and discuss some concepts of geology and how I got those materials and how you can maybe collect your own. For this first week I'm going to cover a question that geologists deal with a lot, and that is, what is the difference between a mineral and a rock? Let's start with the definition of a mineral. A mineral is a naturally occurring, homogeneous solid with a repeating crystalline structure and a consistent composition. Now let's break that down a bit. Naturally occurring rules out things that are only made in weird temperatures and pressures in labs, as well as a lot of those crystal grow kits that you find. They are real crystals and would count as minerals in any other circumstance other than the fact that you made them and they're only made in those kits. Homogeneous just means that the composition doesn't vary throughout the individual mineral. You don't have a bunch of sodium on one side and potassium on the other side. Even if they were at the right ratio for the mineral, that wouldn't count. Solid should be pretty obvious. You can't have a liquid, crystal, or mineral. Most rocks that you see are solid, and when they are in their molten form, they aren't minerals or rocks. The last two qualifications are probably the most important for the mineral. The first of these last two is the repeating crystalline structure. This is the qualifier that rules out naturally occurring glasses, because even though they are natural, homogeneous, and solid, they don't have a repeating crystalline structure. It's just kind of a mishmash of anything that happened to bond to each other in the cooling process. Glass usually cools very quickly, whereas crystals usually take a little more time, at the very least a few weeks. The last qualification is also very important. That's they have a consistent composition. I should probably have included composition ratio in there, because when you look at the formula for a mineral, say, let's take quartz for instance, the formula for quartz is SiO2, which means that for every silicon atom in this mineral, you're going to have 2 oxygen atoms. Each element has its own position in the crystalline structure, and they repeat over and over again to form the mineral at large. A quick note before we go on, I am going to be referring to mineral crystals, and while all minerals do form in crystals, not all things referred to as crystals or crystal are minerals. Being a crystal is just one of the qualifications for being a mineral, and if it doesn't meet all those other 4 qualifications, it doesn't count. But as we're transitioning into rocks, I'm going to need to use the crystal terminology. A rock, like the one I'm holding, is going to have a variety of minerals chemically bonded together. Here you can see a large quartz crystal connected to this large feldspar crystal, and the quartz crystal is also connected to another mica crystal on the other side. That was a pretty easy sample to start out with because all the minerals were large and easy to see. That's not always the case. Take this basalt for instance. Basalt has no discernible crystals on it. But I can assure you I have seen it cut up and under a microscope, and there are crystals there. They're just very small because they form very quickly. The rock that I showed you before is a pegmatite and probably took millions of years to form. Now there are a wide variety of different types of rocks in different classes and families, but they're all going to have the same basic structure of different crystals connected together via chemical bonds. Before we finish up, I want to leave you all with a question to consider over the next week. I have here a sample of what is called rutilated quartz. The clear material is, as you might guess, quartz. The gold-colored material, however, is another mineral called rutile. The rutile takes advantage of the crystal structure of the quartz as a framework to build its own crystals off of. My question for you is this: is rutilated quartz a rock? Or is it 2 minerals that happen to exist in the same place at the same time? Or is it its own mineral? I'd love to hear your thoughts on this, as well as any research you might feel inspired to do on the subject. I'll be discussing the question in more detail in the next video, so until then, rock on. That was dumb, and I apologize. I will come up with a better sign-off.